As far as the packet, I don't really have the time to read the answers right now. That's okay. But hopefully you are paying attention for the tricks or the extra info. Like the one that's talking about how fast the race car is going. I think it was number 8 on the ground. But it's on the ground, and then it asks you what the potential energy is. Yeah, it's 0. It's certainly got a lot of kinetic, but that wasn't the question. So just pay attention for those tricks. Likewise, in the kinetic section, if it tells you like how high the bird is in the tree, but the bird's not moving, what's the kinetic? 0. So a few of these should be 0, so look out for those. Don't be thrown off by extra information.
Do you keep these in here?
I do. You just, whatever, sorry. All right, so 3 slides to go. And our topic today is conservation of kinetic energy. And we've already talked about conservation before. We've talked about conservation of atoms or conservation of mass. What does conservation mean?
Save.
Conservation
What'd you say?
means change between.
Save.
It can change, but it means it's saved.
That's right.
Or conserved, yeah, conserved, kept the same. Like when we did balancing equations, the amount of atoms we started with had to equal the amount of atoms we ended with. So atoms were conserved, conservation of atoms or conservation of mass. Anyway, energy can change forms, but it's never lost. Now, it may appear to be lost largely because of this. Friction. Now, that energy is not lost, it's just hard to keep track of. But technically, friction is producing what type of energy? Heat. Thermal energy. And if we had temperature probes everywhere, maybe we could account for all the lost heat. But all energy is conserved. It can change forms, but it's never really lost. It just maybe changes into a form that we can't keep track of. But anyway, we're going to be talking about some things rolling down a hill, where the bottom of the hill is ground level. So if I'm just talking about a biker rolling down a hill, what type of energy does the biker have at the top of the hill? All potential. In the middle of the hill, halfway down, what do we got? Yeah, some potential, some kinetic. It's now moving, but it is still above ground level. And by the time we get to ground level at the bottom of the hill, what type of energy would the bike have? Yeah, all kinetic, high kinetic. Okay, so you're going to see a bunch of pictures like this in your packet. Sometimes they use a basketball, sometimes they use a car, whatever. And I will give you enough information somewhere to figure out all the rest of the information. So I want you to be able to tell me all the different potential and kinetic energies at these random spots on the hill. At the very top, we will always assume, now not that the car would have to start at 0 kinetic energy, but just to make it a little easier, we're going to assume the car is at rest at the top of the hill. And just maybe just barely gets nudged over the top, a little wind blows it, I don't know. But to make it easy, we'll assume the kinetic energy is 0 at the top. If I tell you the potential at the top is 400,000 joules, what is the total energy anywhere? 400,000 joules. So if the total at any spot is conserved, meaning it stays 400,000 joules, what should the kinetic energy in the middle be? Perfect. Because what does 300,000 and 100,000 add up to? 400,000. The total has to stay the same. Energy can change in between forms, but the total is the same.
The one at the bottom is going to be 400,000.
Perfect.
Oh, yes. This comes.
Wait, so why would...
All the answers are on there. Get it, Smarty.
Sure. At a different spot in the hill, maybe where it's a little higher, maybe it's 200, 200.
Smarty.
Okay, so that's the entire point. Make your totals the same. This is the last slide, right? Last hill? Okay. So bump it up 1 notch. I want to fill in all the missing. This time I'm giving you some specific information. The mass of the car is 1,000 kilograms. The height at position B in the middle of the hill, the vertical height, is 12 meters. and I've randomly told you the kinetic energy in the middle is 500,000. Now, assuming it starts at rest and the bottom is ground level, the first thing I can fill in is a couple zeros. So what is 0 at the top? All right, I think it's easiest to fill in the zeros first. So good, kinetic energy is 0 at the top. What's 0 at the bottom? PE. And for us, that will always be true. 0 joules, OJ.
OJ's in the restaurant.
Okay, now what can I do?
You add it up.
But I don't have anything to add up.
Well, guess what? You go to the middle. You say it's 500,000.
I've got to do the formula. I've got to use this information. All right, so that's where I need my formula. Mass times gravity times height, because I'm told information right at this spot, at spot B. So the mass is 1,000.
Will it ever tell you like the spot, the height of spot A?
Yeah, it might tell you the height at spot A. And I could have done kinetic energy as well. I could have told you speeds at certain spots. And I need calculator help.
117720.
Wow.
Is that right?
Yeah.
Am I missing a 0? 117720? Okay. All right. So, not the easiest number to add, but that's not too bad. So what is the total energy?
Add the joules.
617720.
Yeah, add this all up. Add the kinetic to the potential, I get 6. And then 17720.
What goes on the KE down there? 670.
So if the total should always be 617,000, what should be the KE at the bottom? 617,000, because what plus 0 is that? Well, same thing, 617,000, and the same up top. And hopefully you notice now the top should always be reverse to the bottom. Make sense?
Oh, yeah.
All right.